Okay, so I'm creating this video just to help some of you with the lab. So I think where most people are getting a little lost in is at the end when they're trying to calculate the change in potential energy. So in our lab we have two charges. I think we have a positive and negative. I can't remember, but whatever. So you can extrapolate from here. And then it's asking, in our lab we're trying to ask, what's the change in energy to move an electron from point A to point B to point C? So it doesn't matter. So I mean, I can just choose like 3 points. Maybe this is point A. And over here is point B. Again, it doesn't really matter. And for your lab, you're going to have the 3 specific points. So we're trying to find out how much energy is required to go for an electron to go from A to B. So for us to do that, first what we need to do is actually calculate what is the potential at A, what's the potential at B. So to calculate the potential, you see at A, we can use what's called the superposition principle. So if we can find out the potential caused by the positive charge at A and add it to the potential caused by the negative charge at A, that will give us the overall potential at A. So basically what we're doing is, so at A, potential at A is going to equal to, going to be equal to the potential from the positive charge plus the potential from the negative charge. Okay? So to find that potential from the positive charge, we have to basically find out what is this distance. So this is some distance. We'll call that d1. We'll call this one some d2. And this is potential and energy. They're scalar values, so we don't actually care about direction. So I don't care if this is from like northwest or that is northeast. We just need to know what is the distance from that charge to A. So let's say this one has some charge Q1, let's call this one, and this is some charge Q2. So our potential at A is just going to equal to, well, let's write out the equations first. Potential is KQ over R. So that's the equation for potential. So it's going to be K and multiplied by Q1. And we're going to divide that by D1. And then we're just going to add to it K, Q2, and divide by D2. So this one, because the negative charge, this will be a negative number. Okay, so make sure we actually plug in negative. So you're going to end up with a positive number, then you're going to add a negative number. And that will give us our potential at VA. Afterwards, what we're going to do is we need to find the potential at B. Okay, we're still going to call this Q1, and this is Q2. To find B, we're going to say, oh, what's this distance? We're going to call that D3. And then we say, oh, what's this distance? This is some D4. So if we want to find the potential at B, it's going to equal to K Q1 divided by D3 plus K Q2 divided by D4. So we're getting a different value for potential at VB. So if we want to find out like how, and now we have a value of, we have some VA value over here, we have some VB value. So now we have to kind of picture, we have an electron. Now we have some electron. So we don't actually need to worry about the charge anymore. We just say we have some potential of VA and some potential of VB. And now we have an electron that is going to go from A to B. So we have an electron, it's going to go from A to B. So the change in potential is just going to be the difference of that. So my change in potential, delta V, is equal to potential B minus the potential at A. Okay. And energy, the equation for energy, potential energy, is equal to K QQ QQ over R. So notice how if we look at these two equations, this is just V. So we've already calculated that. So this little q represents the electron charge. Okay. So what we can see is EP, instead of writing KQQ over R, we say, okay, EP is just going to be voltage times Q. If we want to find the change in energy, also known as the work, it's going to be delta V multiplied by Q. So this is what we're trying to solve for right now. That is how much energy it requires to go from A to B. So we say, okay, the change in energy from A to B would be delta V, which we just found right here, multiplied by the charge of an electron. And that's that. And for that, we're saying, okay, then from A to B to some point C. Just repeat it again. Find out what is the potential at VC. Then you go VC minus VB to go in that direction. So hopefully that helps you a little bit with the lab. Again, ask me. I don't want to give away all the individual solutions for it, but again, email me if you still have questions regarding this.